René Descartes was a renowned French mathematician whose most significant work was entitled The Discourse on Method. It was split into 3 parts, one on light and optics, one on meteorology, and the last part, on maths, was called La Géométrie and was published in 1637. In La Géométrie, Descartes united 2 fields of maths, algebra and geometry, when he described a general method to represent geometric figures with algebraic equations. This is today known as Analytic Geometry. For example, the equation y equals x plus 2 can be represented as a straight line. The quadratic equation y equals x squared plus 1 gives a parabola. The cubic equation y equals x cubed is represented by a cubic curve. The equation x squared plus y squared equals r squared, where r is equal to 2, represents a circle of radius 2. Descartes also discovered 3 fundamental principles about 2D Cartesian coordinates. An equation cannot have more than one graph because the same thing happens to each input, so other outputs are impossible. A graph can have more than one equation, but only if the equations are multiples of each other. And finally, the graph of an equation can be empty, that is, it can have no points at all. The impacts of Descartes' work are numerous. This amazing insight that unified geometry and algebra has become extremely important today. In fact, we use Descartes' name to describe the result. We use the Cartesian plane to describe geometric figures with algebraic equations. We also use it to observe the relationship between 2 functional variables, for example, velocity and time. On a velocity-time graph, the gradient represents a constant speed, constant acceleration, or constant deceleration. The coordinate system is also used in tracking and locating planes and ships, and also in your sat-nav, which uses GPS tracking. On a world map, the prime meridian is the y-axis and the equator is the x-axis. Cartesian coordinates are not restricted to 2 dimensions, and it is often useful to consider 3 or more dimensions, especially in real-life applications. Isaac Newton was hugely influenced by Descartes when he invented calculus, which today plays an invaluable role in science, economics, sociology, and engineering. Descartes made contributions to philosophy, psychology, and science, and believed that the key to certainty and credibility was through mathematics. We'd like to finish with a few quotes from Descartes. "I think, therefore I am. It is not enough to have a good mind, the main thing is to use it well. Conquer yourself rather than the world. Divide each difficulty into as many parts as is feasible and necessary to resolve it." Thank you for watching.